So let's remember at the beginning, ya shabab, what we have in section 3.7. It's about the rates of change. So you need to know that if the position function is given, then the distance traveled will be the absolute value between the interval time that you need to calculate on. When you need to find the total distance traveled, you have to consider the different intervals where the velocity is positive and negative, as we will see in the exercises. The velocity is the first derivative of the position function or the displacement function. The acceleration is the first derivative of the velocity. The particle is at rest when the velocity is 0, and the particle is in the positive direction moving forward if the velocity is positive, and if it is negative, it is in the negative direction, which means that it moves backward. And finally, the particle speeds up when the velocity and the acceleration have the same sign, when they are both positive or both negative. And this will happen, of course, when the velocity is positive and increasing or negative and decreasing. And of course, they slow down. It slows down when the velocity and the acceleration have opposite signs. We have mentioned the first exercise in the previous class, and it is related to example number 1, because you know from this section you need only to focus on the ideas of example number 1. The other examples are not included. So we have here a particle that moves according to this law of motion. So this is the position function, the displacement function, which is of course signed by t over 2. طبعا here t is greater than or equal 0, it is time. It is about time, so it is usually positive. Now, we need to find the velocity. It is easy to find the velocity. You will just differentiate this, and you need to recall what is the derivative of sine. It is cosine, and then differentiate what is inside. So the derivative of sine is cosine, and the derivative of pi t over 2, it is pi over 2. Here it is, by using the chain rule. Now, let me choose another color. Now, what you need to do in the next step is to find the velocity at 1. And this is also so easy. To find the velocity at 1, what you will do, you will just put t equals to 2 to 1 in this function here, the velocity function. Just put t equals to 1. And you can see that cosine when t is 1, this will be cosine pi over 2. Cosine pi over 2 is 0. So this means that the velocity will be at rest at 1. I think he will ask about that in the next, yes. So when the particle is at rest, so this means when the velocity is 0. So this implies that pi over 2 cosine pi t over 2 equals to 0. Now, this is not 0, divide both sides by pi over 2, so this is not 0, so the cosine will be 0. Cosine what equals to 0? This is a trigonometric equation, how to solve it. Cosine what equals to 0? So this means that the angle inside cosine equals to what?
90.8.
Pi over 2 plus n pi. The zeros of cosine, ya shabab. Do you remember what are the zeros of cosine theta? They are theta equals to pi over 2 plus n pi. And what are the zeros of sine theta? They are theta equals to 0 plus n pi, which is n pi. So this means that now divide, we need to solve it for t. So divide both sides by, multiply both sides by 2 over pi. So if you multiply by 2 over pi, what you will have? You will have this. 2 will be cancelled. Look, if you multiply by 2, it will be pi t equals to 2 pi. It will be pi cancelled with 2 plus 2 n pi. Then divide by pi, it will be pi. So these are all the interval times or the period of times that at which the particle will be at rest. Like what, for example? Like 1 when n is 0. N here it is non-negative integer because t is positive, so we cannot take negative integers here. So n here it is 1, 2, 3. It is 0, 1, 2, 3, and so on. So it could be at 1, it could be at 3, at 5, and so on. It will be at rest. Now, when the particle moving in the positive direction, so this means what? This means that the velocity is positive. So this means, what is the velocity? The velocity, it is pi over 2 cosine by t over 2. So when this one is positive, you can divide both sides by pi over 2, it is okay. So the question is when cosine is positive. In this case, you need to sketch the graph of cosine. Do you remember, ya shabab, how to sketch the graphs of cosine?
We start from 1 plus 0.
Now you need to find first the period. What is the period? Do you remember how to find the period? It is 2 pi over k. This is k. It will be what? 4. Is that right? So you will draw it from 0 to 4. Do you remember the shape of the maximum here is pi over 2, طبعا. It is not important. Now this is the shape of cosine, shabab. Do you remember that from math 002? Now we need to draw more intervals. Let's go to 8 also. We can draw it to up to 8. Repeat the same. You can, for the negative, we will not do in the left part because we will start from 0 because t, this is t is greater than or equal 0. So this is what we want. This is the graph. Now when it is positive, shabab, this is 4. So the midpoint here, it is 2. This is 1. This is 3. This is 5. This is 6. This is 7, and so on. You got it, shabab? You got the idea? You need to recall how to sketch cosine and sine. Now, it is in the positive direction when it is positive. This is positive here, here, and here. So it is positive from where to where? From 0 to 1.
And from 3 to 5 and 7 to 9.
5 and then so on. So here it is. It is mentioned here. Now, find the total distance traveled during the first 6 seconds. So is it just, so you know, I mentioned this here at the beginning. To find the distance traveled between T1 and T2, just you will take the absolute value of the position function. But of course, this is the case if the function is always, if the velocity here is always positive or always negative, it doesn't change. So you can do that. But here, if you look at this one, the function from 1 to 6, from 0 to 6, the velocity, it changes. It is not always positive or always negative. So it is not only in the same direction. So you cannot, if you did this, you will say for the first 6 seconds, it is the value of the function at 6 minus the value of the function at 0. Which function? The position function, the displacement, because we are talking about the distance. So this will be wrong, ya shabab, because the function, this one, the distance from here to here, the velocity is not always the same. It has different directions. So what you should do in this case, you should consider all the intervals that at which the time or the function will be changed, the time, the direction, the function will, the velocity will be changed. So let's start from 6. So it will be the absolute value of f of 6 minus, now at 6, the velocity is negative. So it will be negative from 5 to 6 here. From here to here, it is negative. So you will subtract f at 5 plus, so you will calculate the distance here. Then you will calculate the distance from here to here, from 5 to 3. F at 5 minus f at 3 plus, now from 5 to 3. From 3 to 1, the velocity is negative. So you will calculate the value of the function at 3 minus the value of the function at 1. Plus the last one, from here to here, the value of the function at 1 minus the value of the function at 0. You can start from here, shabab, then this, then this, then this, but I prefer to do it from the end of the interval to avoid any mistakes. So look here, what is here minus here, it will be plus, so you can do it this way to order them. And this
Doctor,
is the total distance traveled, yes.
But f of 5 will be equal to 0 and f of 3 will be equal to 0.
No problem, it's okay.
Okay.
No problem, let's calculate it if you want. The value of the function at 6, what is the function? What is f of x? What is f of t? F of t, who remembers what is it? Here it is, sine pi over 2, sine, it is sine by t over 2. So if you put t equals to 6, what will happen? If you put t equals to 5, and if you put it like that. So this is, by the way, this is, you said that it will be at 5 and at 3 it will be 0. This is not true. This is the velocity, by the way. Here, what is drawing here, Shabab, is the velocity, not f. This is v. This is the velocity. Okay. So here we are. So this is what I mentioned here. So if you calculate this, Shabab, let's calculate, for example, the first one or the first two ones, and you can continue, طبعا. What is f at 1 minus f at 0? طبعا, what I did, I start from here, Shabab. It is, for me, it is better to start from here. Then go this way, this way, this way. But it is okay if you can start from the beginning. Now, let's take just as one of them to calculate. So this will be f at 1. Come here. And both instead of t, 1. It will be sine what? Pi over 2 minus sine 0. Plus, let's take this one. It will be sine 3 pi, 3 pi over 2. It will be when t is 3 minus when t is 1. It will be sine pi over 2 plus this will be sine pi over 2 is 1 minus sine of 0 is 0 plus this will be sine 3 pi over 2. What is it? It is negative 1 minus sine pi. It is negative 1 because this will be 1 minus 1. And you can continue this way, طبعا يا شباب. So it will be what? It will be 1 minus 0, which is 1. This will be plus equals to 1. This will be negative 2. The absolute value of negative 2 is 2. And you can continue this way, ya shabab, and the final answer will be 6. Any question, ya shabab, regarding this? It is important. If you look at the old exam questions, there are many questions about the total distance traveled. And the idea is just take the sum of the absolute values of the difference between the value of the position function at different interval times where the velocity change its sign. You need طبعا to know that. Now let's move to the next one. Draw a diagram like figure 2. This is of course an example number 1. Draw a diagram for the motion. And this is so easy. You can just find it out from where? From the positive and negative direction. Look from here, or also from the distance traveled also. Now what we have, Shabab, we have, let's say this is the direction that we are going to go through. So this is the start time. This is t equals to 0. So what will happen? What is the function? The function is what? What is f of t? It is sine by t over 2. So when this is s, the distance. Now, when t is 0, this will be s will be 0. Because if you put t equals to 0, s will be 0. Now, in the positive direction, from 0 to 1, it is in the positive direction. So here it is. It will go this way. Up to where? Up to 1. When t is 1, what will happen? When t is 1, it will change direction. S will be what? When t is 1, it will be 1. So it will change direction this way. Up to where? Up to 3. At 3, when t is 3, calculate what is s, and we calculated already. It is also negative 1, and it will change direction. Up to where? Up to 5, and so on. So if you draw just the first 6 seconds, this is what you are going to have. So I showed you how to obtain it. Just start at 0, then at 1 it will change, then it will change at 3 again, then at 5, and so on. So here you can see clearly what we mean by it moves forward, and here it moves backward. This is positive direction, this is negative direction. And at these points, it will be at rest. It will be 0 at this point, the velocity I'm talking about. Here at this, the velocity, not s, the velocity will be 0. Now find the acceleration at time t and after 1 second. The acceleration is the first derivative of the velocity. So do you remember what was the velocity? The velocity, ya shabab, it was pi over 2 cosine by t over 2. If you differentiate this, you will have the derivative of cosine is negative sign. This is negative sign. And you will multiply again by pi over 2. So it will be pi squared over 4. If at 1, when t is 1, it will be sine pi over 2. Sine pi over 2 is 1. So it will be negative this. Negative pi squared over 4. So easy, this one. Now the next one, graph the position and the velocity and the acceleration function. And I told you, you need to remember how to sketch the graphs of cosine and sine. And it is all about that. The graph is here. It is so easy. I sketched the graph of cosine for you. What I did, I sketched this one, the velocity function. What I draw for you before, it was this one, the velocity function. Now, if you draw the original function, which was sine, this is the displacement function, the position function. This is S, and this is cosine. The velocity, the acceleration also, it is sine, but negative. So it will be reflected, look. It is the same, but reflected, and also the altitude of the graph, which called the amplitude. The amplitude here is negative pi over 2 here, negative pi squared over 4. So this one is the acceleration. So I wish that we did it in different colors. Let me color this one, the acceleration. I will make it blue. And we need to compare it now with the velocity. It is important with the velocity, yes. Now this is ya shabab, this is A, and this is V. Look at V and A. What we need to do, we need to decide now when the particle is speeding up. Yalla ya shabab, who can tell me where it is speeding up? Let's start from 0 to 1. From 0 to 1, what do you think? Is it speeding up or slowing down?
Slowing down.
Slowing down.
Why?
Because the acceleration
decreasing.
is decreasing to the downside.
So when the velocity is always decreasing, it will be speeding down, slowing down.
The velocity and acceleration should have the same sign.
Yes. Now the velocity, ya shabab, you know that this is the x-axis. Y above the x-axis, y is positive when the graph is above the x-axis. Here it is negative. So in our case, we have V and A. We will ask about ourselves. Is it positive or negative? Our x-axis here now, it is t. So now from 0 to 1, the velocity above the x-axis or below?
Above.
Above. And the acceleration?
Down.
So the velocity from 0 to 1, the velocity is positive and the acceleration is negative. So it will slow down. This is one way. This is one way to find out. The second way is just look at the velocity itself. The velocity, ya shabab, decreasing or increasing?
Decreasing.
Decreasing. It is decreasing and positive. When it is decreasing and positive, it will slow down. Because it is decreasing, it means its derivative is negative. Its derivative is the velocity, the acceleration. Now, from 1 to 2, from 1 to 2, this is 2. From 1 to 2, ya shabab, the velocity, this is the velocity is negative. From 1 to 2, the velocity is negative. What about the acceleration? From 1 to 2,
Negative also.
Also negative. So here it will speed what? It will speed up because they have the same sign. So here it will speed up. Now, you can know it from the velocity. No need to focus on the acceleration. Look from 1 to 2. Look at the velocity. What happened to the velocity? It is what? Decreasing and what? Decreasing and negative. So when it is decreasing and negative, it will speed up. When it is positive and increasing, it will speed up. When it will slow down if it is decreasing and positive or increasing and negative. Now let's look at it from 2 to 3. From 2 to 3. The acceleration is the acceleration here, A, is positive and the velocity is negative. So it will slow down. From 3 to 4, and you can continue this way now. So ya shabab, to know where the particle is speeding up or slowing down, you can do it in two ways. طبعا if you have the graphs of the velocity and the acceleration, it will be so easy. But if you don't, you can solve them. You can just ask yourself when you can make you can look at example number 1 يا شباب in my slides. You can make a numbers line, you can make a table for the velocity where it is positive, where it is negative, and you can do the same also for the acceleration, and then look where they are, when they have the same sign, when they don't have. No need to sketch the graph if you cannot, if it is difficult for you to sketch the graph. So you can solve them algebraically by making a table of signs. But of course, you can also know it from the velocity only, if you have the graph of the velocity. So the speed, it will speed up when they have the same sign, and it will slow down when V and A, they have opposite signs. I think I mentioned it here for you. No, I didn't mention here that exercise. Look also at exercise number 1. The solution is in the slides. Any question about this? Because also this is one of the most things that they ask about in the old exam questions. So if you have a question from this section, mostly it will be about speeding up and slowing down, positive and negative directions, and of course the total distance traveled. You can, for example, look from 4 to 5. From 4 to 5, it will slow down. Why? This is 5, and this is 4. From 4 to 5, I think we have an example. It will be much easier to illustrate it from here. We have another example here. Graphs of the velocity functions of two particles are shown. This one and this one. This one and this one. Where t is measured in seconds. When each particle is speeding up and when it is slowing down. Look here, this is the graph of the velocity. Now from 0 to 1, it will speed up or slow down?
Speed up.
Speed up.
It will speed up because it is positive and increasing. So the speeding up on the intervals from 0 to 1 and from 2 to 3. Why from 2 to 3 it will speeds up? Because it is decreasing and negative. Now from 1 to 2, it will slow down. Why it will slow down here? Because it is decreasing, it is positive and decreasing. So positive, it means that the velocity is positive. Decreasing, it means the acceleration, its derivative is negative. So they have opposite signs. Similarly here, let me ask some students to check that they got the idea. Let me, for example, ask Naif Al-Jaid. From 1 to 2, ya Naif, what do you think?
Slow down.
From 1 to 2, this one will slow down. Why?
No, actually here it's speeding up because it's positive and increasing.
You are right. Yes. So it will speeds up from 1 to 2 and from 3 to 4. And it will slow down otherwise. The last exercise, ya shabab, it is very easy. It is about a rock that is throwing vertically upward. So when you throw a rock vertically like this way, at sometimes its height will be 0 and it will slow going down. So from the surface of Mars where the velocity, so here the velocity is given, it is 15 meters per second, and its height after t seconds is given this way. This is the height. So the height here, it will represent what, ya shabab? Is it VAF? So it is S. It is the position function.
Position.
So the position, the height is a position. So this is the position function. So this one is equals to f of t. Now, what does he want? What is the velocity of the rock after 2 seconds? So to find the velocity, you will differentiate. So the velocity will be what? The velocity function will be just 15 minus 2 times, I will no need to calculate. I will leave the calculation for you. So just multiply by 2. This is the derivative. Now this is the velocity of the rock after 2 seconds, both t equals to 2 and calculate. You have it. Here it is. It is just the velocity at 2. log. So this one, it is 3.72. Just put t equals to 2. This will give you the velocity of the rock. B, what was part B? In part B, what is the velocity of the rock when its height is 25 meters? So when h is 25, what will be the velocity? طبعا on its way up and on its way down. What does that mean? طبعا at some point here, at some time, it will be the height, h will be 25. And of course, when it is going down also at the same time, at different time, with the same height. So also at another time it will be here. So this means that it is when it is going up here, when it is on its way down. Now what we do to find that? So we will use this. He said that the height is what? 25. So both the height here, both the height equals to 25. So what you will get? 15t minus 1.86 t squared equals to what? To 25. Now you have quadratic equation. This quadratic equation, you need to solve it by what? By the quadratic formula, of course. You have decimals here. So this will be minus 25 equals to 0. You need to use the 1.86 plus or minus the square root over 2 times 15. And here you will square it. You know the quadratic formula, shabab. You need a calculator to continue solving this problem. طبعا if they give you similar problem, it will be easier with no need to calculate. So if you did this, you will have these two solutions. These are the two values of t at which the height will be 25. So the height will be 25 when time is 2.35 seconds and when it is 5.71 seconds. Now go and substitute the first one because he asking about the velocity. So go to the velocity function, put t equals to t1 and calculate it. Here it is. The velocity when it is going upward after at that time, it will be 6 point something. And when it is going in its way down, it will be negative. And it is clear that here why the velocity here is negative, because it is decreasing, it is going down. It was positive when it is going upward in the positive direction, and down here is the negative direction.
دكتور معلش بس ما فهمت ليش اللي جبنا الكوادراتيك ايكويجن هنا، ما فهمت ليش جبناه.
هو يقول لك ايش الفيلوسيتي لما يكون الهايت 25. فاحنا حطينا الاتش تساوي 25 ودنا نعرف التايم. At which time when the height is 25, what will be the time? يعني after how many seconds or how many minutes here? He's asking about seconds or minutes? Seconds. After how many seconds the height will be 25?
ايوه بس احنا اخذنا الديريفاتيف، يعني ليش كتبنا الكوادراتيك ايكويجن؟
طيب لحظه لحظه read the question. What is the velocity of the rock when its height is 25? طيب كيف نجيب الفيلوسيتي لما يكون الهايت 25? Forget about all what I did. What you will do?
I will put
velocity
to 25.
الفيلوسيتي 25
h.
طيب هذا اللي سويناه، حطينا بدل ال h 25. وين احط بدل ال h 25؟ هذه الايكويشن اللي فيها ال h، حط فيها بدل ال h 25.
ايوه بس ايوه انا ما فهمت القانون العام اللي كتبته، ما فهمتش العلاقه.
طيب الان انت ودك تعرف يعني عشان تجيب الفيلوسيتي هي فانكشن في التايم ولا لا؟ It is a function of time. كيف تعرف الحين الفيلوسيتي كم؟ يعني عندما كان الارتفاع 25 ايش راح تكون الفيلوسيتي؟ كيف اجيب الفيلوسيتي؟ الفيلوسيتي هي فانكشن في التايم، احنا جبناها قبل قلنا هي 15 minus 3.72 t. هذه هي الفيلوسيتي فانكشن. عشان احسبها، عشان اعرف وش هي، احتاج اعرف التي عشان اعوض بايش هنا؟ فعندما الاتش ب 25 كم راح يكون التايم؟ يعني لما توصل البارتيكل الارتفاع اللي هو 25 كم راح يكون التايم؟ I need to solve this equation which is for t, and this equation is quadratic equation. You need to solve this quadratic equation for t, And we did, and this was the time that the solutions that we obtained. So at these 2 seconds, after 2 seconds and after 5 seconds, 0.7, the height here, h will be here 25, and also h here will be 25. And this is when it is going up, and this is when it is going down. And what we did, we take these two values of time, we substitute it in the velocity function, and it gives me the velocity when the height is 25. You got it?
Yes.
Okay, Shabab, let's now go to 3.9. This section is about related rates. To understand or to deal with this, the ideas of this section, you need to recall some geometric formulas. It is important. For the triangles, for example, what is the area? What is the circumference? For the circle also. For the sectors, if you have an arc of a circle. For the sphere, this is important. For the sphere, what is the velocity? What is the surface area? For the cylinder, for the cone. Recall this, yes, it is important. And you need also to follow these steps when you solve any related rates problem. Read it carefully, understand it. Draw a diagram, introduce your notation, decide what is given, what is unknown, and of course, write the equation. This is the most important step. Find the relationship between the variables that you have. And you need to use the chain rule to differentiate and substitute at the end. Warning, ya shabab, don't substitute before differentiating. You should differentiate and then substitute. Go over these, ya shabab, with details, please. Let's start with the first one. Each side of a square, so what we have here, you need, as I said, ya shabab, you need to sketch a diagram. So we have square. Each side of square, so let x be the side of the square. This will be x, this will be x, all of them will be x because it is square. So let's take one of them is enough. So each side of square is increasing at a rate of 6 centimeters. So this is the rate of change. So when you have a rate of change, you have a derivative. So this will represent what, ya shabab? If this is x, if the side of the square is x, what will be the rate of its change? It is what?
Its derivative.
It will be dx dt. The rate of change of x. So now what we have dx dt. He said it is increasing, so it is positive. So it is 6 centimeters per second. Now, at what rate is the area of the square is increasing when the area of the square is 16 centimeters? So as I said, ya shabab, it is important for you to decide here what is given, what is unknown. What is given, what is unknown. Now, what is given is dx dt equals to 6. Be careful about the units. They may play with the units here, centimeter per second, and here it is 16 centimeters. So the same units. So this is what is given. What is required, ya shabab? What we need to find? What is the unknown? The unknown is what? The rate of the area. So let's say that the area, what we want to find is the rate of the area. So dA dt. This is what we want. When? Not always, طبعا. It should be specific, shabab. Always. They will not ask you just about this. They will ask you about this when other data are given. So when what? When what? The rate of the area of the square increasing when the area of the square is 16. So this is when A is 16 centimeters squared. So let's just deal with the numbers. Forget about the units now because they are the same units. Don't worry about them. So we have dx dt and we need to find dA dt. Now the most important step is what is the relationship between x and a. I have two variables, x and
X
a.
squared.
What is the relationship between them?
A equal to x squared.
What is the area of the square? The area of the square here, a equals to x squared. So what will be dA dt? Let me do it here. What will be dA dt? You will differentiate now. So dA dt will be what? 2x dx dt. We will differentiate both sides with respect to t. So x and a here are both functions of time. So now I have dA dt. No, I need it. Now I need to find the 2 dx dt. It is 1. This one, it is 6, not 1. Now what is x? So he gave me
It's
this.
4, I think.
When a is 16, what will be a from here? This means that x squared equals to 16 because a it is x squared. So what is x?
4.
It's 4. We will not take negative 4 here, Shabab, because we are talking about length of a side. So here it is 4. And it will be 2 times 4 times 6, which is what? 48. So it will be 48 centimeter cubed because this area per second. The final answer is there and you can check. Is there any question, Shabab, before going to the next one? So the most important relationship here, it is this, a equals to x squared. If you cannot find it, you cannot solve the problem. Also, how to represent the given and the unknown. Always do it. These are the most important steps. What is given, what is unknown, what is the relationship? And of course, the figure, it will help you. The figure will help you to find the relationship. Let's take another example. I will give you, Shabab, 1 minute. 1 minute to read it and solve it. Not completely, Shabab. Just decide what is given, what is unknown. Sketch the graph if you can, if you need, no need sometimes. And also the relationship between the variables. What is the relationship? Take a paper and pen, ya Shabab, and start trying. So what do we have here? We have sphere, spherical ball. So it is a sphere. Increasing at what is increasing? The radius. So let's say r is increasing at a rate. So we have here dr dt equals to 2. You can know, ya Shabab, also from the unit. What is this rate? It is centimeter. If it was centimeter cubed, for example, it will be volume. If it is centimeter squared, it will be area. طيب. At what rate is the surface area? So the surface area, let's call it what? Surface area, let's call it S or A, no problem. So he asking about the rate of the surface area. So he is asking about ds dt. When what? He will not ask about it in general. When what? Of the ball increasing when the radius is 8. So this is when r is 8. Look at the units. Are they the same? Centimeter, centimeter, minute, minute. Or don't worry about the units. Here, they are the same. So now my variables, ya Shabab, are r and s. What is the relationship between r and s? I need to find
S equal to 4 pi r squared.
S equals to 4 by r squared. This is the formula of the surface area of the what? Of the sphere. You need, Shabab, to recall it. You don't need to recall it all the times. Here it is. A here, what is A? A is the area. He is talking about the surface area here because it is 3D object. So A or S here, it is the 4 by r squared. It is the surface area of the sphere. Sometimes they will give you this in the exams, but of course, sometimes not. So you have to be aware about them. So now what you will do, just so easy now, ya Shabab. You will differentiate both sides. So it will be 8 by don't forget r, to r, dr dt. We differentiate both sides for t by using the chain rule. Now I have this. Khalas. Substitute, direct, it is solved. This will be the final answer. Is that clear? Any question, يا شباب? ترى لا تفكرون هاي الأسئلة صعبة. It is very easy. Just you need to know the technique. If you know the technique, you can solve it easily. Let's go to another one. Okay, we have here a plane. What about the time? We still have time. We have a plane here. Read, يا شباب, the problem. take you a paper and pen and start working on the problem, please. A plane here flying horizontally at an altitude of 2 kilometers. So this is the ground. You can think about it. This is the ground. And this is the plane. So the altitude of the plane is 2 kilometers. Continue reading. Just this is for you at the beginning. A plane flying horizontally at an altitude of 2 kilometers and the speed of 8 kilometers per hour. So we have the speed of the plane. So here, what we can consider it here. You know that it is the velocity here, but the velocity here, it is the rate of change of what? We need to represent it as a rate of change because it is kilometer per hour. So it will be the distance, if you call the distance s per time. So we need to find the s. This s is, what is it? So just to keep this in mind, I need to represent this as a rate of change. A rate of change of what? Of the distance, of course. Passes directly over a radar station. So this is the plane, this is the radar station. So on the ground, of course. Passes directly over a radar station. Find, this the sentence is done up to. Now, find the rate at which the distance from the plane to the station is increasing. When is 3 kilometers away from the station? When the plane will move, it will keep moving. He is asking about the distance, not the horizontal distance, the vertical distance. This one is given. It is 2. Khalas, it is fixed. He is asking about the rate at which the distance from the plane, this is the plane now, after some times, it will be the distance. He asking about the rate here. Find the rate at which the distance from the plane to the station increasing when it's 3 kilometers away from the station. So now the question is, what is d? Let's call this one y. The question is, what is dy dt? And let's call this one x. The horizontal distance between them and the station. So now he's asking about dy dt, the rate at which the distance from the plane to the station is increasing when it is 3 kilometers away from the station. So when what? When this 3 kilometers is what? Is x. Is that right? So when x is 3, when it is 3, is it x or y, Shabab? We need to decide, is this x or y?
I think it's y.
Yes, he said find the rate at which the distance from the plane to the stations, look at this word, the distance from the plane to the station is increasing when it is 3 kilometers away from the station. So this is the distance also, the distance from the plane to the station. So it is y, not x. Okay, so let's, we can of course adjust our parameters if we find this, something wrong. Now what will be this 800 kilometers now? What is this? Is it dx dt? Of course, it is dx dt that we mentioned here. So dx dt here, it is 800 kilometers. By the way, this question is different from the previous ones. I forgot to mention that. He is asking about these issues one by one, Shabab. So he said, what quantities are given in this problem? So these are the quantities given in this problem. Let x be the horizontal distance traveled by the plane, and let y be the distance from the plane to the station. So we have horizontal distance traveled by the plane, and we have distance between the station and the plane. This is the answer of part A. These are the quantities. And of course, the quantities that they are given, it is dx dt, 800 kilometers per hour. This is what is given. The question is, what is unknown? What is the unknown? The unknown is dy dt when y is 3. This is what is given, what is required, what is unknown. Draw a picture of the situation for any time t. This is the picture. We already sketched the figure. Here it is. So this is 2, this is x, this is y. Now write an equation that relates the quantities. This is the most important part in solving this problem, inshallah. So what is the equation that relates these quantities? This is triangle problem. Ask yourself, ya shabab, your problem, is it square? Is it a cube? It is sphere? Is it a circle? Is it a triangle, right triangle or not? So what is your problem? So here it is the what, ya shabab? It is right triangle problem. So how to relate this? You will use Pythagorean theorem. So what we have here, we have y squared equals to x squared plus 2 squared, should be plus 4. So this is the relationship between these two variables. This is the most important step. Now what you will do, finish solving this problem. So easy. You will just differentiate both sides with respect to the time. All the variables here are with respect to time, functions of time, plus the derivative of 4 is 0. Now divide both sides. This means that dy dt will be just 2 will cancel with x over y, dx dt. Now you have this, you have x, no, we don't, we have y. So this will be equals to 3, and this will be 800. Now what will be x, ya shabab? If y is 3, what will be x? X at that time will be what? Will be 9 minus
Root 5.
the square root of 5. So this will be square root of 5. And this will give you the final answer. What is dy dt? Any question, ya shabab? So it is important to do any problem, ya shabab, through this 4 or 5 steps. Ask yourself, what is given? What is unknown? What is the figure of the problem? What is the relationship between the quantities? And after that, it will be easy. Just it is a matter of differentiation. Excellent. Let's go to another problem. Let's see how many problems we still have. Oh, we still have 2 problems. So I think I'm gonna just mention the ideas. This is also a very interesting problem. We have here a man start walking north. So this is north. He's traveling this way. So if the distance here is x, this will be the x dt. It is 1.2. From a point B, so he's starting from a point here. 5 minutes later, a woman starts walking south. So, some woman starts moving down like this. South, it was north. Let's say this is the distance here is y, so dy dt is equals to 1.6. From a point 200 meter due east of P. So the distance between this woman and that man is 200 meter. At what rate are the people moving apart? 15 minutes after the woman starts walking. So now the question is about what will be the distance between the man is here and the woman after 15, let's say after 15 minutes, it will be here. So this is the woman, this is the man. He is asking about the distance between them. What will be the distance between them? The rate of the change, the distance between them. So let's call this one Z. So the question now is, what is dz dt? So what we will do, ya shabab, you will first of all introduce your notation. X will be what, y will be what. And of course, this will be the problem, the figure of the problem. Now we need to find the relationship between X, Y, and Z. How to find the relationship between X, Y, and Z? You need to just do this easy trick. You will have here, ya shabab, right triangle. This will be a right triangle. Use Pythagorean theorem. So this is Y, this is X, this is Y. So this will be, all of this distance will be X plus Y. Now, according to Pythagorean theorem, what will be Z squared? Z squared will be equals to what? X plus Y all squared plus 200 squared. Now, this is the main relationship between your variables. Halas, you have this, you can solve it now. What you will do, you will differentiate both sides with respect to the time. So it will be 2Z dz dt equals to, you can continue solving this way. And the final answer is here. What is X, what is Y? This is also important because after 50 minutes, the trick here, after 15 minutes, and also you know that the woman is starting 5 minutes later. So you need to find X when the time is 15. So this will be X, this will be Y, this will be Z, and after that you will substitute to find what will be the Z dt. I bought here the main parts of the solution for you, Shabab, to do it by yourself. And also I want you, Shabab, to solve this problem also, which is about equilateral triangle. What will be the area of the equilateral triangle? You know that the area of any square, of any triangle, it is the half of the base times the height. But if it is the same, you know that it will be just the same. This is x, this is x, this is x. So you can calculate it by using the idea of the half of x. This is the half of the base, and times the height. The height here will be, of course, by using Pythagorean theorem also, will be square root of 3x. So this will be square root of 3 over 2x squared. So this is the relationship between them. And after that, differentiate and solve, you will find this final answer. Okay, I think we are done. If we have time next class, inshallah, we will also mention these ideas and solve, inshallah, 3.10 problems. If you have any questions, Shabab, I still have time. If any questions is here, I can give you some time to answer your questions. But always, Shabab, I'm taking the attendance from the report, so don't think that I'm not taking the attendance. Please remind me next time to show you your absences if you are worried about it. I'm calculating the absences every class.